Hello, welcome back to Chapter 1, Section 9, Introduction to Parent Functions. In the last video, I introduced the idea of finding data sets, graphing them, and seeing if there is a algebraic way to describe that data set. In this example, we're really going to do this. So some scientists have collected some data involving ocean waves. They were able to estimate the height of the wave and compare it to the current wind speed, because we think that when it's windier, the waves are going to be higher. So maybe there's a way of predicting one over the other. So if we could figure out how high the waves were, if we're sitting at our beach house and we're looking at the waves, maybe we could use that to predict what the wind is going to be. All right, so you can read it. An oceanographer wants to determine a model that estimates wind speed based on wave height. So we're going to graph this. We're going to see if it matches up with one of the parent functions we know, and then we're going to use it to make an estimation about more data. We're going to use that to draw conclusions about data that we don't have, which is kind of the whole point of math and science together. So pay real close attention. Now this time I'm not going to do this with Desmos. You saw the previous videos where we did use Desmos. So in this one, I'm going to do it with like a straight up graph. Now, again, I'm not saying this time we're going to draw that you have to draw it with a graph. I'm just providing a chance for you to see both ways of doing it. Okay? So I'm going to try to put both of these in the screen at the same time. I don't know if it's going to work. There we go. All right. So I kind of made my grid here, and it looks like this is going to be the wave height, and of course that's in feet, and over here this will be the wind speed, and this is actually in knots, which is nautical miles. Look it up. Last time I checked, I think it's like 1.15, what's the word for like the miles we use? I really should have remembered that. Okay, but anyway, if you're ever gonna get into sailing, or if you go into the Navy, you're gonna have to switch things to knots. So 2 feet waves are going to be about 8.8. Now notice I'm gonna have to estimate here, so it's not gonna be perfect. So 2's right here, and 8.8, I'm going by ones. Here's 5, so I go, here's 5, 6, 7, 8, and 8.8 is just below 9, so it's about right there. 4, which is right here, is going to go up to 12.4. So here's 4, and then here's 10, 11, 12, and 12.4 is about halfway. And notice I'm just estimating, it's okay. Make that a little bit bigger so it matches up the other one. 6 feet waves are going to be about 15.2, so just a little bit more than 15. So I'm going to come up here, and let's say about right there, just slightly above 15. 8-foot waves, 8's right here, and that's going to go up to 17.5, which here's 15 again, 16, 17, about right there. And 10-foot waves are going to be just below 20. So here's 10, and just below 20 is right there. Okay. Well, this is awkward because it looks like those are all in a line. And notice I did estimate, but let's see if we can match that up. I know I did approximate, but I didn't round it off that far. So my first thought was that, man, that looks really, really close to being a linear function. But it doesn't look like it. It kind of looks like it's going this way, and it starts to slightly curve out. So, and I wish I had another marker here that wasn't black. I didn't. But it kind of looks like I'm doing this. And it's really kind of hard to see, but yeah, that's not straight. That's actually a curve. Okay. It would have also been nice if the wind was 0 or if the wave height was 0, what would be the wind? I'm guessing, just based on my experience, that when there's no wind, there's no waves, and that's like a really nice clear day to go out kayaking. So I'm also guessing that maybe I would go right here. And if that's the case, then yeah, if I started here, I would go up here, but then I start to turn directions this way. So that one's a little hard, I admit, but let's see if it matches up with any of our graphs. So I'm going to say that I don't think it's a linear function because it's not perfectly straight. I don't think it's quadratic because quadratic, and again, I don't have negative height, I don't have negative wind speed. So I wouldn't have this side here, I'd only have this side. But this side goes this way and then curves up. That's not what's happened. If it was quadratic, it would go this way and start to turn and go up. Same thing with cubic. I wouldn't have negative here, but it would turn to the, like as I'm driving, if I'm driving, I'm looking down, I'd be making a left turn. So again, it'd start here and go this way. But it does seem like it does match up with the square root function. So I'm going to make the call and say we think that the parent function is f of x equals square root of x, and that the family is the square root family, which is actually a subdivision of the radical family, but don't worry about that yet. And I'm guessing that we would probably need to collect more data to see, which is something that's going to come up in science. The last thing we're going to check is we're going to use this to estimate the wave height when the wind speed is 10. So if we're going to reverse this, if the wind is 10 knots, 10 knots is right here, and I'm going to estimate that it's about right there. So I'm going to come down to my x and say like right there. So again, this is 1, 2, 3. So at 10 knots, it looks like the waves, here's 1 foot, 2 foot, are approximately 2.5 feet. And again, oh, you didn't even see that. Sorry, I got to move that over. Every now and then I got to look at my iPad. At 10 knots, the waves are approximately 2.5 feet. That doesn't mean that it's actually that. That's my prediction. And then, of course, I need to collect more data to find that out. Okay, see you in the next video.